Let's talk about one of the most important and most deliciously wrong ideas in the entire history of science. We're talking about the first ever model of the atom, an idea that involved pudding, and one that basically set the stage for, well, all of modern physics. So let me just start by asking you this. What could an atom, the tiny building block of everything, possibly have in common with a chocolate chip cookie? And no, this isn't the start of a bad joke. The answer is actually a huge stepping stone in science that completely changed how we see the universe. Yep, you heard me right. We're about to find out how a simple snack became the perfect way to explain one of the biggest scientific puzzles of the day. But before we get to the cookie part, we need to understand why scientists were so puzzled in the first place. All right, let's hop in our time machine and go back. Before 1897, the thinking was that atoms were the absolute smallest things possible. Just tiny, solid, unbreakable little marbles. But then, a physicist named J.J. Thomson discovered something even smaller inside the atom, the negatively charged electron. And this was a bombshell. It meant atoms weren't unbreakable after all, and it created a brand new puzzle for everyone to solve. So this discovery just threw a huge wrench in the works. Suddenly, the question wasn't if an atom could be broken down, but what the heck did it look like on the inside? Scientists had to figure out how this new tiny piece, the electron, fit into the bigger picture. Okay, and here's the real head-scratcher. Scientists already knew that overall, atoms have no electrical charge, they're neutral. But Thomson just found these negative particles inside them. So if you've got negative stuff in there, there has to be some positive stuff somewhere to balance it all out. The massive question was, where is that positive charge and what does it look like? Well, in 1904, Thomson stepped up and said, I think I've got it. And to explain this crazy, invisible world of the atom, he came up with an idea that anyone could understand, because it came straight from a dessert menu. Thomson basically said, imagine the atom is like cookie dough. That whole lump of dough is just a big sphere of positive charge. And scattered all through it, the chocolate chips. Those are the tiny negative electrons, just kind of stuck in there. The positive dough perfectly balances out the negative chips, and boom, the whole cookie is neutral. Pretty clever, right? This whole idea got the official name, the Plum pudding model. Yeah, I know, most of us don't eat plum pudding these days, but it was a big deal back then. The concept is exactly the same as the cookie, a big sphere of positive pudding with negative plums just dotted throughout. But listen, this wasn't just some fun thought experiment over dessert. There was some real science here. For Thomson's model to even make sense, it had to follow two really important rules. Okay, rule number one. The atom is basically this big, fuzzy ball of positive stuff, and the little negative electrons are just embedded inside. And rule number two, and this is the big one, the entire atom as a whole has to be electrically neutral. That's the key to the whole idea. So how does that work? It's really just simple math. For the atom to be neutral, the total positive charge from the pudding has to perfectly cancel out the total negative charge from all the electron plums. So if the pudding has a charge of, say, plus 10, you need exactly enough electrons to add up to minus 10. Plus 10 and minus 10 gives you a net charge of 0, perfectly balanced. And you know what? For its time, this was a genius model. It was the very first real attempt to actually picture what was going on inside an atom. But, and there's always a but in science, isn't there? It turned out this delicious model had some pretty big cracks. So where did it go wrong? Well, first off, it was missing something huge, a nucleus. We now know all the positive charge is packed into a tiny, dense core. Thomson's model just had it spread out like jam. Second, it couldn't really explain what was stopping all those negative electrons from just pushing each other away and flying out of the pudding. And maybe the biggest problem of all, it was just a really, really good guess. There was no experiment to actually prove it. So if the atom isn't a cookie, or a pudding, or a watermelon, then what on earth is it? Well, answering that question became the next great mission for scientists. In fact, it was the flaws in Thomson's model that inspired people like Ernest Rutherford to design new experiments that would end up completely shattering the whole plum pudding idea. But here's the thing, and it's really crucial to remember. Just because the model was wrong doesn't mean it was a failure. Not at all. In the history of science, this was an absolutely revolutionary first step. When you get right down to it, Thomson's greatest legacy wasn't the model itself, but the discovery that made it necessary. By finding the electron, he completely shattered the ancient idea that atoms were the end of the line. He proved they had smaller parts, and in doing so, he basically kicked down the door to the entire field of particle physics. Which leaves us with this final, really interesting thought. How can an idea that's technically wrong end up changing the world? It just goes to show you that in science, progress isn't always about being right. Sometimes it's about coming up with a bold new idea, even a flawed one, that pushes the next person to test it, to break it, and to build something even better in its place.